Humans have been using fossil fuels for over 150 years. And as their use increased, so did the release of greenhouse gases that are produced when these fuels are burned for heating, lighting, and transportation purposes. In 2019, 63% of electricity was produced by fossil fuels globally. To reduce CO2 emissions and local air pollution, the world needs to rapidly shift towards renewable technologies that emit low carbon. Moreover, this last semester, especially in Europe, the energy bills have gone through the roof. Only in the last 3 years, the electricity prices have almost tripled. To better understand the situation, we conducted interviews and a survey. More than 60% of people think that renewable energy can be the solution to this crisis, while others claim that nuclear power should be reconsidered. They did not miss the chance to complain about the rising of the bills, hoping it would only be a temporary problem. Mark Jacobson, a climatologist from Stanford University, in a BBC interview claimed that in the long run, renewable energies, wind, solar, and water are the solution. Not only this would help with global warming, but also reduce the global expenses from 12 trillion per year to only 7 trillion. The solution came to us when we visited the Enactus partner, SNAR. We met the manager Ludovico Giordani, who introduced us to Alessandro Benetti, who was working on a project based on the patent of engineer Domenico Bozano that had been progressing quite slowly for a couple of years because the lack of funds and people who would commit their time to the project. But because of the recent crisis hitting our world, the authorities wanted this project back to life. Our common goal was what moved us to collaborate with them for a better world for everyone. That's how we started to work on the Owcm, oscillating water column motor, a machine that produces clean electricity by the waves of the sea that are unstoppable.
The principle operating of the Owcm is simple. It can be considered like a water engine fixed on a dam. A system is implemented through the installation of 5 modules in series. Each module consists of a float that can oscillate through the wave motion of the sea. The oscillation activates a hydraulic pump that takes the water from the bottom of the machine and brings it upwards. During the oscillation, the water column rises until it arrives at the top of the dam. The water is then left in free fall until it reaches a compensation basin connected to a turbine with alternator that generates electricity. The water coming out of the turbine is fed back into the port. Wave height between 1 and 2 meters guarantee optimal operating condition. However, the system can also support higher waves. The upper limit is around 8 meters. In the case of a calm sea, the modules can be connected to a single generator in order to keep the flow of water. In this way, the rotation of the turbine is maintained. This system is simpler than hydroelectric plants, which are based on the same principle of free water flow. The performance increases as the size of the system increases. The main advantages are the production of clean electricity by the waves that are active continuously 24/7, which can also be alternated to the production of hydrogen. The production of energy allows the ships stationed in the port to be able to turn off the engines. Consequently, they can reduce diesel consumption. The desalination of water is also possible through electrolysis. The desalinated water can then be used for the irrigation or as drinkable water. The system also recycles the internal port waters, currently affected from little circulation and increase in temperature and dirt. Moreover, the modules act as a breakwater to avoid the direct impact of the waves on the dam. By dissipating the waves, the barrier becomes stronger and more durable. In conclusion, there are some points of strength that the Owcm system has than the other generator, which are based on the wave motion. This system is completely supported by the dam. This makes it easier to install and maintain because it does not need to be reached far from the coast. Moreover, being fixed on a solid structure, in case of breakage part of the system, it's not lost in the sea, as happened with other prototypes. Finally, the machine does not in any way hinder the navigation, nor it affect the environment aesthetically, nor the marine life of sea creature, letting life continue as it did before.
The first prototype was designed for the Gulf of Genoa and attached to the rim. According to statistics, the Gulf of Genoa has 183 good days with the waves up to 2 meters. Italy, with its 8,000 kilometers of coast and the Mediterranean Sea, are the perfect area to position the machine. With the world having almost 800,000 kilometers of coast, we could fill the global demand for electricity. The first few models cost 1.2 million euros each, making a system cost about 5 to 6 millions. But having industrialized the process of production will be able to reduce the cost for the fourth. For example, the Genoa Harbour Dam is 7.2 kilometers long. In that space, we'll be able to place a maximum of 1,500 models for the cost of only 266 millions. The annual maintenance would cost about 19 million euros, which would bring many new jobs. Annually, the machines are going to be able to pump 2 billion meter cubes of potable water and 239 gigawatt hours of electricity, with annual net revenue of 31 million euros. Will be able to impact 150,000 families by letting their housing with clean, renewable energy produced by the Owcm. To make the machine even more green, we propose to return to traditional construction, up to the total abolition of the use of cement by promoting the use of materials such as stone, sand, lime, brick, porcelain, clay, and wood. How Romans built Pantheon, Colosseum, bridges and stairs are still standing and operating after centuries. While today Portland cement is the most widely used building material in the world, it contributes about 7% to carbon dioxide emissions. As Giuseppe Verdi said, let's go back to the old and it will be progress. Now, our idea is to carry out this project in a sustainable way for green energy production. This project was possible thanks to the collaboration with many experts. We had the support of Ludovico Giordani as our business advisor and Alessandro Giovanni Benetti, with whom we were working to progress this project. We worked with Professor Piero Galli to understand what natural materials could substitute and existing ones of the machine, but aiming not only to maintain the same or even higher durability, but also making the system even more environmental friendly. We contacted Stefano Damiola to better understand if in fact the prototype can be realized with green materials without altering the function of the machine.
The digitalization of the plants is certainly the way to improve the efficiency of existing resources and therefore increase the production of energy from renewable sources. The installation of intelligent sensors allows to obtain data to understand the state of the health of the machines, even remotely. This data allows to optimize the planning of maintenance. This increases the efficiency and maximize energy production. The reduction of the risk of critical events allows to extend the life of the plants and reduce strongly the costs that permit to obtain significant advantages in terms of business continuity. Precise mathematical models are essential to reproduce accurately the behavior, validate the result, and understand the performance of the wave energy converter. Waves are typically described in terms of power per meter of wavefront, but there are some other different representation in math form depending on the application. Defining the wave model, we have different possible techniques to describe the system. Incoming wave trains, wave structure interaction, hydrodynamic interaction between the parts and their influence on the performance are just some of the aspects to consider. At the state-of-the-art exist different approaches to model the nonlinear interaction between the wave and the device, all with their advantages and disadvantages. This plan has some particular advantages. First of all, it's based on simple technology, that means simplification of management and maintenance. The benefits don't stop here. Over the supply of electricity for the boats, the system permits to reuse the water from the turbines to clean up the harbor's waters. The water from turbines can be used as a source of irrigation. That could be a considerable improvement for a sector of agriculture. Other possible applications are the production and transport of clean water and the cleaning of area that requires recycling action. Another advantage of this technology is the saving of space and the protection from the possible environmental damage. Not being placed in the middle of the sea, as most technologies of this type, it doesn't constitute sources of risk to the environment or for the navigation. After the presentation, our team say thank you for your attention and for your time.